Just days ago, 3I Atlas, an interstellar comet racing past the sun, sent back a signal no one expected. From a region too close to the solar glare to study came a chemical fingerprint, water from another star. This isn't just data, it's a turning point, but some say it feels like a warning. In early 2024, a faint streak of light appeared in the nightly scan of the Atlas Survey Telescope in Hawaii. At first, it looked like just another comet, a frozen wanderer drifting through the darkness. But within days, calculations told a very different story. Its trajectory was hyperbolic, moving too fast to be bound by the sun's gravity. Whatever this object was, it wasn't from here. Astronomers designated it 3I Atlas, the third confirmed interstellar object ever detected by humanity. To grasp its importance, you need to look back. The first, 1I/Oumuamua, arrived in 2017. It darted through space like a sliver of metal, accelerating in ways we still can't fully explain. Then came 2I/Borisov in 2019, a true comet, icy, evaporating, exactly what theory predicted an interstellar visitor should look like. But 3I Atlas sits between them, a strange hybrid. Its surface flashes unpredictably, and its coma brightens and dims, as if reacting to something unseen. Unlike Oumuamua, it carries a dense cloud of vapor, but unlike Borisov, it behaves erratically, wobbling off its expected path. This combination of traits has puzzled every observatory tracking it. It is both a traveler and an anomaly, a cosmic fragment shaped by physics we barely understand. Spectroscopic analysis hints at compounds unfamiliar to our solar chemistry, elements possibly forged in a different stellar nursery, billions of years and light years away. Where did it come from? What forces shaped it? And most haunting of all, why did a radio signal, measured only weeks after its detection, seem to originate from its direction? 3I Atlas isn't just another comet racing through space. It may be the first messenger to bring proof that even across the vast emptiness between stars, something connects us all. It began quietly, an ordinary night inside the control room of the Very Large Array in New Mexico. Screens flickered, equipment hummed, and a routine calibration drifted toward closure. Then, without warning, one of the spectrographs lit up. A narrowband frequency emerged, steady, rhythmic, deliberate. The technician on duty frowned. "That can't be right," he whispered. He ran a diagnostic check. Nothing unusual, no reflections, no interference, yet the frequency persisted, pulsing every 2.3 seconds in near-perfect intervals. Could it be a glitch? Someone asked. They cross-checked the signal with a second array. The same pattern appeared again. Exact amplitude, exact timing. Within an hour, alert messages reached observatories around the world. Stations in Chile, Japan, and South Africa confirmed it. The signal was real, and it came from the coordinates of 3I Atlas inside the room. Atmosphere shifted from routine to disbelief. Dozens of scientists crowded around monitors as lines of data scrolled. It wasn't random background noise, the signal repeated in harmonic sequences, too organized for coincidence, too faint for human origin. Every protocol activated at once. Data logs were locked, external lines cut, power backups engaged. The control room fell into focused silence. Only the rhythmic pulse remained, translating into a sound almost like a heartbeat through the speakers. A few remembered the "wow" signal from 1977, a similar unexplained event that vanished after 72 seconds. Could this be a continuation? A pattern resurfacing after nearly half a century? Minutes stretched into hours as they traced every possible source. Satellites, radar reflections, atmospheric echoes, even cosmic rays, all failed to explain it. Then came the realization that changed the mood entirely. When plotted against ATLAS's trajectory, the signal shifted with the object's motion, tracking perfectly as it crossed the sky. It wasn't from Earth, it was moving with the comet. The lead scientist made the call. "All systems record. Don't interrupt. We may be witnessing history." For the next 6 hours, the faint frequency held steady before dissolving back into silence. Gone as suddenly as it appeared, no one slept that night. The world hadn't yet been told, but within the walls of that observatory, everyone felt the same quiet truth. Whatever had just spoken across space, it chose that moment, that object, and that frequency to be heard. Morning broke over the observatories of the world, but the questions had only deepened. Was the signal real, or another artifact tricking the instrument? In science, belief is never enough. It demands verification, one step at a time. The first team to respond was from the European Southern Observatory in Chile. They ran a mirror analysis of the same coordinates, finding the same narrowband pulse still embedded in archived data. Next came confirmation from the Square Kilometre Array in South Africa and Australia. 2 hemispheres, 1 voice. The signal held true, but evidence alone wasn't enough. Error had to be ruled out. So, over the next 48 hours, every piece of equipment that touched the data was recalibrated. Cables replaced, antennas retuned, algorithms recompiled. Specialists hunted for interference, solar, terrestrial, even military. Nothing matched the exact harmonic ratio of the signal. Then came the cross-disciplinary audit. Physicists, chemists, and radio engineers rechecked the frequency ranges for any known natural emitter. Pulsars, masers, quasars, all eliminated. The signal's modulation didn't fit any astrophysical profile. It behaved not as an object powered by fusion or magnetism, but as something releasing energy intermittently, deliberately. Finally, the data repositories were synchronized. Independent observatories compared timestamps, orientation, and Doppler shifts relative to 3I Atlas's motion. And there it was. The pulse moved in tandem with the comet's path, each tiny variation explained by its rotation and velocity. When the final report arrived, it contained just one conclusion: all known sources of error excluded. The signal originates from the precise calculated position of 3I Atlas. Inside the control centers, silence took over again. But this time, it was different. Relief replaced confusion. Skepticism gave way to awe. Something extraordinary had just been confirmed the hard way. The impossible had survived every test, and for the first time in human history, an interstellar object wasn't just passing through our system, it was transmitting. At first, the signal seemed undecipherable, a series of repeating tones with no clear origin. But when the data was converted into a frequency map, something remarkable appeared. The pattern matched the spectral imprint of hydroxyl radical, OH, the unmistakable fingerprint of water. When sunlight or ultraviolet radiation strikes a comet's icy surface, it breaks water molecules apart. Those reactions release hydroxyl emissions detectable in the radio spectrum. That was the signal. Not a message, not words. It was chemistry singing across the stars. 3I Atlas wasn't sending anything artificial. It was evaporating, and that evaporation carried water molecules born outside our solar system. For the first time, humanity had found direct evidence of interstellar water, crossing unimaginable distances to reach us. The implications were breathtaking. Water is not just a liquid, it is a code, the molecule that bridges matter and life. Every drop tells a story about where it came from. The star that forged its oxygen, the dust clouds that shaped its hydrogen. Scientists realized the discovery went beyond astronomy. It was planetary archaeology on a galactic scale, a confirmation that the ingredients of life travel freely between stars. Some say the cosmos speaks in mathematics, others in light. But this moment suggested something more poetic, that the universe speaks in chemistry, and in the fading whisper of a comet from another world, the message was clear. Life's building blocks are not confined to any one system. They drift, timeless, patient, and persistent, waiting to be found. When the analysis of 3I Atlas's signal reached the final stage, one comparison froze the room. Its frequency curve, the exact arrangement of peaks and pauses, looked strikingly familiar. Back in 1977, the Big Ear Radio Telescope in Ohio recorded a signal just like it. A narrowband radio burst from deep space that lasted 72 seconds. It was so distinct that astronomer Jerry Amon circled it on the computer printout and wrote a single word in the margin: wow. For decades, that event remained an unsolved mystery. Dismissed by many as a one-time anomaly, no source was ever found. No repetition, no second chance, until now. When scientists overlaid the wow signal's frequency pattern with that of 3I Atlas, the resemblance was undeniable. Same bandwidth, almost identical intensity decay. Even the modulation slope matched within error range. Could it be a coincidence? Possibly. But the odds of two unrelated cosmic events producing the same signal shape are vanishingly small. It was as if, 48 years later, the universe had whispered the same sound again, just from a different corner of the sky. Speculation spread quickly, but the research teams stayed cautious. Astronomy is not built on patterns that feel meaningful. It is built on evidence that repeats under scrutiny. Still, the echo of that word, wow, lingered. It reminded everyone that maybe discovery isn't about new signals at all, but about learning how to listen differently each time they return. The 3I Atlas doesn't behave like any comet ever recorded. Its path bends subtly, as if some invisible current were steering it off its predicted course. Astronomers adjusted their models dozens of times, yet its motion kept defying gravity's clean equations. When sunlight strikes its surface, the object brightens and darkens unpredictably. No consistent period, no stable rotation. It tumbles through space like a fragment unsure of its own shape. Some observations even suggest jets of vapor bursting from random points, not from a single nucleus. Its tail adds another mystery. Instead of flowing smoothly behind, it twists and folds backward, as if resisting the solar wind. Spectral analysis reveals traces of exotic compounds, carbon chains and silicates unseen in any comet of our solar family. Temperature readings also raise questions. Even while far from the sun, Atlas shows surface activity that shouldn't exist at such distances. Something within it is warming and cooling in patterns science can't yet explain. For planetary scientists, this object is both a laboratory and a riddle. It moves like a comet, spins like debris, and reacts like something altogether new. Each observation uncovers another contradiction, but it's precisely those contradictions that make 3I Atlas so valuable. Because whenever nature breaks its own rules, it leaves behind the clues to a deeper understanding. In less than a single human lifetime, 3 visitors from beyond our solar system have crossed our path. Each one arrived unannounced, silent, brief, and transformative. The first, 1I/Oumuamua, was spotted in 2017. It moved faster than any comet we'd ever seen, reflecting sunlight in sharp, metallic flashes. Its acceleration as it left our system defied gravity alone, igniting debate that still hasn't cooled. Then came 2I/Borisov in 2019, a more familiar sight, glowing with gas and dust, behaving like the comets that circle our sun. It reminded astronomers that interstellar travelers can still obey the rules of nature. Now 3I Atlas completes the pattern. Not a shard like Oumuamua, not a true comet like Borisov, but something in between. Complex, unstable, unpredictable. It carries the water-rich chemistry of Borisov with the mysterious dynamics of Oumuamua. Together, these three objects form a timeline of revelation. Each one pushes the boundary of what we expect from the stars beyond our own. Each one adds a new line to the story of cosmic exchange, the proof that our solar system is not isolated, but open to visitors from the unknown. And if three have reached us in less than a decade, the question now feels inevitable. How many more are already on their way? Once the excitement faded, the real work began. Every frame of data, every second of signal, was re-examined as if preparing evidence for a cosmic courtroom. 10 observatories participated in the audit. Each handled its own raw files, refusing to share intermediate results until the process was complete. Only when every calibration, every noise pattern, and every timestamp matched perfectly did they merge the datasets. The reconstructed signal was clean, no distortion, no ground reflection, no radio contamination. Analyzed under multiple algorithms, it revealed a consistent spectral ratio matching hydroxyl resonance at 18 centimeters. That meant one thing: water molecules being broken apart by ultraviolet radiation, proof of natural chemistry, not technology. But confirmation demanded more. The team then simulated every physical condition known to cause false positives: instrumental echoes, satellite interference, even planetary radar spillover. None reproduced the exact harmonic shape of Atlas's emission. Finally, statistical modeling put the odds of coincidence at less than 1 in 10,000 in scientific terms. That crosses the threshold between doubt and fact. With peer review complete, the verdict was unanimous. The signal from 3I Atlas is authentic, originating from the object itself, powered by interstellar water breaking in sunlight. In that moment, skepticism gave way to clarity. Humanity had confirmed an impossible observation, and in doing so, took one quiet step closer to understanding the chemistry that connects us to every world beyond our own. 3I Atlas is already fading into the distant dark, racing back toward the interstellar vastness it came from. But its discovery has changed how we watch the skies. New telescopes like the Vera Rubin Observatory, LUVOIR, and citizen science sky networks are now scanning every night, ready for the next signal. Because if 3 visitors have reached us in less than a decade, the next one could arrive any moment, carrying another clue to our shared cosmic origin. The universe just proved it can speak in chemistry. Now, it's our turn to keep listening. If you want to follow this unfolding story of interstellar messengers, subscribe and stay with us, because the next signal might already be on its way.